Write the equilibrium constant expression, Kc, for reaction 1 based on the law of mass action. The balanced equation for reaction 1 is SO2 plus 1 over 2O2 is in equilibrium with SO3 quad. The equilibrium constant expression, K1, for this reaction is K1 equals SO3 over SO2, O2, to the power 1/2. Write the equilibrium constant expression, Kc, for reaction 2. The balanced equation for reaction 2 is 2SO3 is in equilibrium with 2SO2 plus O2 quad. The equilibrium constant expression, K2, for this reaction is K2 equals SO2 to the power 2, O2, over SO3 to the power 2. Analyze the relationship by manipulating the chemical equations. To transform reaction 1 into reaction 2, two successive mathematical manipulations must be performed. Step A. Reverse the reaction. Reversing reaction 1 swaps the positions of the reactants and products. SO3 is in equilibrium with SO2 plus 1 over 2O2. When a chemical reaction is reversed, its equilibrium constant is the reciprocal of the original. K reversed equals 1 over K1. Step B. Multiply the coefficients. To match the stoichiometry of reaction 2, we must multiply all coefficients of the reversed reaction by a factor of 2. 2SO3 is in equilibrium with 2SO2 plus O2 when the stoichiometric coefficients of a reaction are multiplied by a factor n. Its equilibrium constant is raised to the power of n. K2 equals K reversed to the power 2 equals 1 over K1 to the power 2 is equal to 1 over K1 to the power 2. Verify the mathematical relationship algebraically. Substitute the expression for K1 into our derived relationship to confirm it mathematically simplifies to the expression for K2. 1 over K1 to the power 2 is equal to 1 over frac SO3 SO2 O2 to the power 1/2 to the power 2 is equal to 1 over frac SO3 to the power 2 SO2 to the power 2 O2 equals SO2 to the power 2 O2 over SO3 to the power 2 equals K2. This algebraic verification confirms that K2 is equal to 1/K1 to the power 2, identifying option C as the correct choice. The correct answer is option C. K2 equals 1/K1 to the power 2.